Okay, hypothesis testing for correlation. So if we have two quantitative variables, your null hypothesis when you're doing this is always going to be that there is no association between the two variables. The correlation coefficient, remember, if you have no correlation, the correlation coefficient would be 0. That means your null hypothesis is always going to be written. Null hypothesis is that the population correlation coefficient is equal to 0. Remember the way you say that is rho. Rho is equal to 0. So you are saying out in the world, if you had every single point between the explanatory and the response variable in the entire population, and then you plotted those points would look like a scattered mess. There would be no correlation at all. 0 correlation. The correlation coefficient for the entire population would be 0. We are hypothesizing about the entire population. You then go out and you collect a sample and you get your sample correlation coefficient. You're going to use your sample correlation coefficient to determine the strength of evidence that you have against this null hypothesis. Your alternative hypothesis when you do these is always going to be two-sided. So you have a null hypothesis that there's no correlation. Your alternative hypothesis is that there is correlation. It could be the case that the population correlation coefficient is positive, meaning there is correlation and the data is actually tending to increase, or that there is correlation and the data is tending to decrease. But you always just start off by saying null hypothesis is there's no correlation, alternative is that there is correlation. You don't make any guesses about whether or not the correlation is positive or negative. You just say two-sided. Okay, so when we do this with a simulator, you are going to have a sample. Okay, so I made a little sketch here of just a nice quick sample that I hope you see very much resembles a line. So I picked some points here that I hope you see seem to have a strong correlation. I would expect a very high correlation coefficient like R equals 0.9. What we're going to do in the simulator when we do this hypothesis testing is we're going to take this sample set of points where each x is mapped to a specific y value, where my x equals 2 is paired with y equals 5. My x equals 3 is paired with 7. This x equals 3 is paired with 6, and so forth. What we're going to do is we're going to randomly reassign the x's to different y's. So we're going to have the computer take x equals 2, and instead of assigning it to 5, it's going to randomly take these y values and assign x equals 2 to one of the other y values, like 6 or 8 or 9 or 10. And then we'll have each of the x's randomly assigned to the different y's. Why are we doing this? We're going to do it this way because our null hypothesis is that rho is equal to 0. That is what we're assuming is true. No correlation. Meaning, these x's are in no way tied to specific y's in a manner that is linear like this. We are assuming it's true that the x's are just randomly being assigned to these y's, that they are just random dots. There's no association between them. It's just like they were randomly drawn from a hat. So if that were really true, which we're assuming it's true, remember we assume the null hypothesis is true. If that were really true, then there's nothing special about these y's and how they were assigned with the x's. They were just randomly put there. So when we have the computer create this and randomly assign them, it's going to show us what those sample correlation coefficients should look like if they're randomly assigned. Then we'll compare it to our reality of what we actually observed. This is actually what we observed. These x's being assigned to these y's, and the correlation coefficient we get there is probably like 0.9 or something. We're going to compare it to that and see how much evidence we have against this assumption of being randomly assigned x's and y's. All right. That might be a hard concept for you to wrap your mind around. We're going to actually go ahead and look through it with an example. Go to the next video and take a look.